Welcome back from the ad break, and let's continue with our lesson. So now we are going to work with more of those application questions where we are going to work with the figures that we used in the practice questions, but now we are going to come up with those algebraic equations. Let's look at the first a geometric pattern here. So of course we had those blocks and we did find the number of blocks. In the first figure we had 1 block, in the second figure we had 4 blocks, and in the third figure we had 9 blocks. Then we went and we drew the number of blocks there for the fourth figure. So now, since as well we have seen what the pattern looks like or how the pattern is being represented, do you remember? Do you remember the relationship between the term number and the term itself? Well, in the first one, we said it was 1 squared. So we take the term number or the number for the figure or the position of the figure and we square it. What about the second one? Well, the second one, if we say 2 squared, then definitely we can see there that we get the number of blocks there, which is that 4. What about the third figure there? So in the third figure, we know that we say 3 squared, and that of course gave us that 9. I'm sure you can see how the pattern is working now. For that fourth figure, it would be the 4 squared, which is of course our 16. So that will make it easier for us to find that fifth and that sixth figure, or the number of blocks in that fifth and that sixth figure. So what is it in that fifth figure? Yes, it is going to be 5 squared, which of course is 25. And then what about that sixth figure? That is going to be 36, and that 36 of course comes from that 6 squared. So that is how now the pattern, or the relationship between the pattern and the relationship between the term number and the term itself, or because we are dealing with figures, that would be the relationship between the position of the figure and the number of blocks in that figure. How would we represent this algebraically? Now, our question for B there, we are still working with number 1. It says they determine the algebraic rule for this pattern and how many blocks will make up the 10th figure. Of course, for us to make up or to find the number of blocks in that 10th figure, we need first the algebraic rule. Now, we've already seen the pattern there. We said it is 1 squared and 2 squared and 3 squared and 4 squared and so forth. But now we need to represent this algebraically, meaning we need our equation or our algebraic rule. That is going to be the position of the picture, and we just square it. So we are going to represent that saying n squared, as we can see. And now that we have that algebraic rule, it is going to be easier for us to calculate the 10th figure, or the number of blocks that will make up that 10th figure. That is just going to be 10 squared, and of course that is going to be equals to 100, and that is how many blocks will make up that 10th figure. Let's move on to our next question. Do you remember those sticks that were making up that house-like figure? Well, here we are again, and with the table already filled out up until the 6th term, of course we did find that term there. But now, for us to continue and write down the 10th term, the 25th term, and the 70th term, we need to find that algebraic representation or that algebraic rule. So, how are we going to find that? So looking at the table here below, we can see that our first term is 6, which means that the first figure had 6 sticks. Second term is 11 and the third term is 16. What rule did we notice here? Well, we saw that from the first term to the second term, we add 5. From the second term to the third term, we add 5. And from the third term to the fourth term, we are adding 5. What is this plus 5 here? Yes, you remembered well, this is the constant difference. So as we can see, there is a constant difference that is being added to these numbers so that we can get the next number of sticks that will be in the next figure. So how can we get a rule for this pattern? Well, we can start with the constant difference. We know that will be multiplied by the position of that figure. So from here, we know that we are going to add or subtract a constant. So as we are going to add or subtract a constant, let's use the first term just to figure out what is happening here. So that is 5 multiplied by 1, and we are going to add or subtract a constant so that we can get to the first term, which is our 6. So how did we move from 5 multiplied by 1, which is 5, and then how do we get to 6? Of course, we are going to add 1. Let's choose any other term and see if the same applies to that term. Let's take the 6th term, which we know is 31. So we are going to say 5 multiplied by 6. We are going to add or subtract a constant to get to 31. Now, what is 5 multiplied by 6? Of course, yes, the answer is 30. And from 30, we only need to add 1 so that we can get to that 6th term, which is 31. So what does this mean for our rule? Our rule is the constant difference multiplied by the term number, and from there we are going to add a 1. So how do we find the 10th term? Now this is going to be 5 multiplied by 10 plus 1, that is going to give us a 51. What about the 25th term? The 25th term is going to be 5 multiplied by 25, and when we add 1, the answer there is going to be 126. And what is going to be our 70th term? Of course, this is going to be 5 multiplied by that 70, and when we add 1, our answer is going to be 351. So we are going to just fill out those values in our table. 51 for the 10th term, 126 for the 25th term, and 351 for that 70th term. So this means that the 70th figure is going to have 351 sticks while we are continuing with this pattern. Now moving on to our last application question. Remember those blocks that we were shading in? Well, here is the pattern again, and of course we already shaded in that 4th block there. So our table is already filled out with the first 4 blocks. Now let's determine the algebraic rule for this pattern, and then we are going to fill out the rest of the table. So as we remember, we had only 1 block in the first figure, and of course we are looking at those shaded blocks. Then we had 5 blocks in the next figure, and we had 9 blocks in the next figure. So did we see how we are moving from the first figure to the next figure? Yes, as discussed previously, we are adding 4. So each time we go to the next figure, we are just adding a 4. So that, of course, is going to help us in coming up with that algebraic rule. So remember, that 4 is a constant difference. So we are going to start with our constant difference here, which is a 4. We are going to multiply that by our term number, and we are going to add or subtract a constant. So we are going to use our first term, or any term that you want to use really, so that we can get that constant value. So we are going to say 4 multiplied by 1 because we are working with the first term, and we need to add or subtract a constant so that our answer is 1. So what do you think that constant is, and are we going to add or subtract? Well, 4 multiplied by 1 is 4, and how do we get to 1? Yes, we are going to subtract that 3. Then We are going to use any other term. In this case, we can use the fourth term. Then we can say 4 multiplied, so 4 from the constant difference multiplied by 4 from the term number, because we are working with the fourth term, and then we are going to add or subtract a number or a constant so that we can get to our fourth term, which is 13. So 4 multiplied by 4 is 16. Now how do we move from 16 to 13? Yes, we are going to subtract 3. So it's quite clear that that constant that we need is actually a minus 3. So our rule now is looking like this, where we are going to say it's the 4 from the constant difference multiplied by the term number, and we are subtracting 3. Now going back to our table and filling out the rest of our table, for our fifth term and our sixth term, we can just continue adding that 4, and that of course is going to give us 17, and we add that 4 again, that is going to, we add that 4 again, that of course is going to give us that 21. But what about now that 10th term? So our 10th term is going to be 4 multiplied by 10 minus 3. And what is 4 multiplied by 10? That is 40. When we minus 3, we are going to get a 37. What about the 15th term? So the 15th term is going to be now our 4 multiplied by 15, and when we subtract 3, we are going to get, well, 4 multiplied by 15 is 60, and when we subtract 3, we are going to get a 57. What about the 50th term? Or rather the 60th term? What about the 60th term? Remember, all we need to do is just multiply by 4 and subtract 3. So 60 multiplied by 4 is 240. And when we subtract 3, it's going to be 237. Then what about the 100th term? Well, when we multiply 100 by 4, that is 400. And when we subtract 3, that is going to give us 397. So that is our whole table filled out using our algebraic rule. Let's quickly go to an ad break, and then we'll see you just now.